One important aspect of multi-threaded programming in Java is coordinating the activities among multiple concurrent Java threads. Unlike a situation in which we have multiple processes communicating via some type of inter-process communication mechanisms, when we have multiple threads executing within the context of a single process, care must be taken to make sure these threads do not interfere with each other when they're updating shared data. We might also want to ensure that the order in which certain activities happen among multiple concurrent threads is consistent. In the Java language, every object instance has an intrinsic lock associated with it. This lock is often referred to as an object's monitor in the Java documentation. In this tutorial, we're going to take a look at how we can coordinate multiple threads by manipulating an object's lock via synchronized methods and the object wait and the object notify all method. So let's say we want to write a program that simulates a horse race. In our program, we're going to model each horse as a separate thread of execution. And to make things more interesting from a thread's perspective, we're going to require each thread to stop and get a drink at a water trough after they run each lap. But there's only one water trough available, and while the horses will run the actual laps concurrently, only one horse can drink from the trough at a time. So horses are going to have to wait their turn at the trough if other horses are already in line. So I've organized our horse race simulation into four simple classes. The horse class is going to model the behavior of every individual horse, and the race class is going to model the race itself. There's going to be one instance of the race class, and we're going to use it to coordinate the starting lineup as well as the idea of crossing the finish line. They also have a water trough class, and this is going to model our single shared water trough resource. And horses are going to drink from this water trough every time they finish a lap. And then finally we have this horse race main, which is basically our main program, and it's going to create all of our simulation objects and start up the race itself. So let's take a look first at how we model horses. So we have a horse class, and recall that in this case, every horse is going to be a concurrent thread. And you'll remember from our previous tutorial that we create threads in Java by creating classes that implement the Java runnable interface. And then we pass an instance of a runnable object to a Java thread object. So here we have a class, horse, that implements runnable. And our constructor receives the name of the horse, so we're going to give each horse a name so we can keep track of it. And it's also going to receive a race instance and a water trough instance. If we scroll down to the run method, we can see that the algorithm that each thread is going to execute. So each horse is going to start by lining up here at the beginning of the at the starting line. And we do this by calling the get ready to race method on our race object. And we'll look at the implementation of that method in more detail momentarily. Second, each horse is going to go into a loop of 3 iterations. And you'll see that in the loop it alternates between running a lap and then getting a drink. And then finally a horse is going to acknowledge it's finished by calling cross finish line on the race object itself. So next let's look at the water trough implementation. So our water trough class models the notion of a horse taking a drink. So we're going to assume that horses drink 1 to 3 seconds, they're very fast, before resuming their next lap. And we're going to accomplish this by simply generating a random number between 1 and 3 seconds. And recall that the we have this restriction that only one horse can drink from the trough at the same time. So in Java, we can accomplish this by simply adding the word synchronized to the method. And when we do this, Java automatically sets the intrinsic lock that's associated with the object instance and ensures that no other thread can enter this or any other synchronized method on this object until the thread holding the lock either exits the synchronized method or gives it up in some other way. And we'll look at these other ways momentarily when we look at the object wait method. So in this particular case, we're guaranteed that all the invocations on our watertrough.getDrink method are going to be serialized. They are not going to be interleaved. So they're all going to enter and exit and treat this method as an atomic operation. So that's all there is to our water trough implementation. Now let's look and see how we use other Java thread coordination features in our horse race simulation.